Dave, aka the Guru, and another tutorial on Gamesalad. In this video, we're going to look at some other ways that we can stop an actor's movement in the physics engine. So let's go ahead and we'll take our little player dude here. And what we're going to do is we can see we've got our simulated gravity on him and he falls down. And let's go ahead and just get rid of that little platform so it's not in our way. And there are a couple ways that we can actually stop an actor's movement in mid-flight. So let's look at a couple of those ways. So let's just, I have this prototype unbroken. We're still going to keep all our movement rules in here. And we have our accelerate going down. So let's go ahead into the prototype because that's the only place we can make self attributes. And I'm going to make an integer, and then I'm going to make a couple of real attributes. And I'm going to go ahead and call this one stop, the integer, and motion x, and motion y. Now these two are real because in motion and velocity we want decimal places, and the other one's just going to be a trigger. We don't need them. So first of all, let's go ahead and just build out our trigger. So let me go ahead and make a rule here, and we'll just start labeling stuff. So this is what we're going to do to make this stop change in the number so we can watch it. So we're just going to say when actor receives event touches press, because I'm going to do this by pressing the our little player actor here. And we're going to go ahead and say when touches press, we're going to go ahead and we're going to use the mod function. And I have a video on the mod function. This is basically just going to give us a slim way in the code to change this stop variable between 1 and 0. And you can see my video on the mod function and where I give a complete explanation on it. So we're going to go ahead and we'll just grab the mod function. We'll come back. We're going to do some math. So we'll add another bracket. Excuse me, open bracket. And we're just going to grab that stop plus 1, close bracket 2. And basically this little function here is going to give us the ability to change between 1 and 0 on each press. It'll change. It'll go to 1, then when I press again, it'll go to 0. Pretty simple, and I have a more detailed explanation. So we've got our little trigger in place, and that's going to jog this variable like a switch back and forth. So now one of the things that we're going to do is we're going to go ahead and we're going to capture the velocity that our actor is falling at when we change this trigger. So 0 is going to be our default. Means that we don't want anything to be messed with. So then let's go ahead and let's just make a rule, and we'll call this capture. And we're going to go ahead and we're going to say when attribute self stop equals 1, because it'll either be 1 or 0. So when we touch it and we want it to stop motion, we're going to go ahead and we're going to take a snapshot of the velocity of the actor at that moment. And since we're just falling on the Y, we'll just capture the Y. So we'll go player, motion, linear velocity, Y, and we're going to, we're going to change attribute player, motion Y to its velocity, its current velocity, which we'll get under the motion tab, linear velocity Y. So we're going to take a snapshot of that. And then what we'll do is we'll come down and we'll grab a constraint attribute right after it, and we'll say once we've snapshotted your velocity, we're going to go ahead and change your velocity on the Y. We're going to just hold it at 0. So basically what this is going to do is it's going to go ahead, and when we change this, it's going to capture the velocity to 0. So now one of the things we need to do is if we're going to go ahead and capture the velocity and we're going to stop our actor, we need to go ahead and stop this accelerate behavior from functioning during this time. So let's go ahead and just embed that in a rule, and we'll just say when attribute is 0, player stop equals 0, go ahead and accelerate, and when you're not, capture the velocity and stop the actor. So let's go ahead and just preview that, and as you'll see when I click on it, it stops. and the actor just sits there kind of in a paused state. So we've got its linear velocity set to 0, and we captured its self-motion linear velocity to this position. So now that we've got the actor stopping, what we want to do is set it back on its course. Because if we just reinstituted it here back to 0, we would start all over again at our acceleration at 300, and we wouldn't achieve the level of acceleration that we had already gone through since we have traveled a certain distance. So let's go ahead and I can quickly copy this rule just to make it a little easier, and we'll just call this restart or resume. So we'll just go ahead and let's close this up. So we're going to say when it's 0, we're going to go ahead and switch this around. So we're going to say we're going to change the player's motion linear velocity y to our captured velocity. And then we're going to go ahead and it's going to change it back to the captured velocity that we have. So let's go ahead and just test that, and we see it's falling down. We click it, and we've now captured the velocity, and we click it, and we see it returns to its accelerated velocity. Because if we just, let's shut this off for a second, and we'll go back in, and we'll see if we stop it and then start it. See how we just start again at the slow point? So we're starting all over again from 0. But if we turn this back on, and we see how it starts to fall faster, and then we're still getting its velocity captured, and then placing it back in. And so we want this resume here back down the bottom, because what we want to do is basically once we start this accelerate, we're going to go ahead and override it. So we're going to go ahead and it's going to, even though this accelerate behavior is going to come in, we're going to go ahead and just override it here and bump the velocity back up to where we captured it at, thereby bypassing, in essence, this accelerate behavior at the current condition. So that's one way we can stop and pause actors in their position. And another way we can do it is, and we can use these same attributes here, and we'll leave our switch in place. And one of the ways that we can also do this is we can go ahead and go into our capture rule, and we could say in here, let's go ahead and get rid of these two, and let's go ahead and we're going to capture its current position. Okay, so we're going to say capture your position X, so it's a player. So we're going to change the attribute motion X, which we'll just say is position X now. Doesn't matter what the variable's named. And we'll go ahead and say capture the position X when we touch. And let's capture, let's go ahead and go to motion Y, and we're going to capture the player position Y. So we're going to go ahead and capture those two instances in there, and then we can go ahead and grab a couple constraint attributes and throw it in there, and we can say once we've captured it, then go ahead and freeze that position. So we'll say your position X, go ahead and stay put at the captured position, motion X, and self position Y to player position to this one, motion Y. And so now what we're going to do is when it's 1, we're going to go ahead and capture its position, and then we're going to go ahead and freeze it at that position. And then when it goes back, we're just going to release it. We'll close this rule off for now to return the velocity. And we'll just go ahead and preview it so we have our actor. And as you can see, we've frozen the position by its capturing it, and then we can put it back down, and it'll fall down at the velocity that way. But once again, it's gonna it's going to start back on this. It's going to start back on this accelerate behavior here. And this would actually work better if, let's say, we took a move behavior. If we were using them, because this is where different techniques work best for different behaviors. So in the first example I showed you where we were capturing the acceleration of an actor, okay, and then we were going down this way, it gives us a much more solid, because in the last one with accelerate, you saw the actor still kind of wiggles around a little bit and whatever. That's because we're just freezing the velocity, and that doesn't work as like a real direct freezing. So let's say that, in this instance, let's just go back here for a second. So let's say in this instance, so in the last instance, it works good for, if we want to freeze something, and but we're not worried about other things colliding with it. Because if we freeze that at its linear velocity, constrained it to 0, it's not going to be a hard, like nailing the thing down. It still can be influenced by coming into contact with things that it's collidable in, and can push it off its path and such. So if we were using, and that's the best way with accelerate to capture, because acceleration is a velocity over time. And so if you want to keep it realistic, you want to capture the velocity that the actor is at, because velocity is speed, it's speed built up over time. So as we travel this distance, our speed is going to increase. It's not going to be at 300 yet, the accelerate that we put at. So we want to capture the realism of that. Now, if we want to have a situation where we want this actor to be frozen, and we really want it to be able to sustain collidability of other objects, we would go ahead and we would come in and we would want to use the move behavior. Because with the move behavior now, we're dealing with speed, and speed is a consistent. So it doesn't matter that where we capture it and freeze it based on its position. It will continue to, it's just going to start back up at that 300 speed. Because that's the way move works. It starts from the get-go at 300 and will travel consistently at that 300 unless it is bounced off of or comes in contact with another object that will increase its velocity based on some kind of impact. So as we can see here with a, must have changed, I got to change this direction to 270. And so now, when we're using the move behavior, if we grab it, we see we freeze it out, we've stopped the movement, and this can now collide with objects, and it'll stay there because we're freezing it directly on its position. And then if we go ahead and click it again, you'll see that it moves consistently. So there are different techniques that we use in Gamesalad, really depending on the type of behavior that we're using. So with a move behavior, I would recommend this course of action with freezing an actor. And with an accelerate behavior, we would want to use the other bits of code that we built where we were constraining the velocity to 0, capturing the velocity, and moving it back. So now when you're designing your game, this is where you start to get into picking different behaviors that are appropriate for what you want to do. And so let's just, for example, let's go ahead and let me go ahead and grab that little platform and show you. So let's grab that little platform, and I'll make it big here so my capture zone doesn't have to, I don't have to really get accurate with this. And so let's go ahead and just move this in a direction. So I'm just gonna, let me push this back a little bit. Let me unlock this prototype. Let me push this back a little bit so I can have some, let me move it up closer so I can make this happen pretty decent. So let's go ahead and let's go into our actor, and let me just make sure on this fixed rotation, we don't want any bounce. And friction and density can stay there, and we've got it colliding with our player actor, which is fine. So let's just go ahead and we'll grab a move behavior, and we're just going to move that in that direction, and we'll just slow this down to like 100 here right now, and we'll make it relative to the scene. And we're going to go ahead and we'll have this collide with our little player. So I'll drop it, and then as you're going to see, it's going to collide and it's going to stop. It's not going to move this object at all. So now let's go ahead back and let's just switch our little player actor back to what we were doing before. So let me go ahead and I'm just going to copy this right here, this little rule. And let's just go ahead and let's do that. Let's get rid of that. So self motion X. So let's go back and we'll grab the player's motion linear velocity X. And we'll capture the player's motion linear velocity Y. And then we'll go ahead and we'll say player motion linear velocity X to our captured. And then, well, actually our linear velocity X, we're going to go ahead and we're going to say 0. Sorry. We're going to freeze the velocity. So we're going to say self motion linear velocity Y to 0. So we're just going to freeze it at 0. And then we're going to come down and we'll just go ahead and put this back on. So when we resume, and we'll just grab this, change attribute linear velocity Y and self motion physical linear velocity Y. Oh, I'm sorry, I need X here. Player motion linear velocity X to our player captured X. And so let's go ahead and we'll take a look at it in this instance, and I'll stop it. And as you're going to see, it's going to move the actor now. And then I can click it and it's going to keep going. So capturing the linear velocity like that doesn't work in those situations where we expect there to be impact with our player or an object when we want to freeze its position momentarily or otherwise under any type of condition or circumstances we want to generate. And so this is why knowing all the different techniques that we can use in the physics engine, and this is why planning out what's happening in your game, what kind of things you expect are going to dictate what kind of behaviors you're going to use in the physics engine, whether it be accelerate or move and whatnot, and then how you're going to do your capturing. So as I've shown right there, when using accelerate, and you've got something like, say, a cannonball that's going to be fired and you want to stop it in midair or something, and then continue on its course at its proper velocity so that its impact speeds are all correct, then you would want to use accelerates and you would want to capture their velocity. If you were doing something where you're expecting the object that you're freezing to collide with other objects and you don't want it to be moved off its path, then we would be using the method that I showed you, and you'd be using the move behavior, and then we would be using the self-position constraint that I showed you. And so those are two different techniques to really accomplish similar objectives, but they each have their own pros and cons. And so this is why it's so important that we learn and study all these different methods so that when we're going in and designing our games, we know which behaviors to use for depending on the style and the things that we plan on happening in our game. And then that allows us to begin drawing out our code using proper behaviors, using proper techniques, so that we don't just start building something and then realize, oh, now this isn't going to work. I want this to happen. And now I've been capturing acceleration using accelerate behaviors, and then you have to start going in and rebuilding your game, the mechanics of your game, and it can throw everything off. Depending on how you built your game, it can become a domino effect in how it impacts everything, because then you change something with the move behavior and then you're like, oh, I'm not getting the same impacts, or I'm not getting this or that, and it just dominoes. This is why it's really important to learn all these different aspects before you really get into designing your game. So anyways, this is part 4 of the physics engine. This is Dave, the guru. I'll see you in the next video.